what I would like to show you is security scanning. So of course, security is important. You don't want your web app to be used for spamming or cryptocurrency mining, or you don't want your users' data to be lost or get into hands of others. So you want to secure your application. And now there are many layers to that, and many layers to enforcing or ensuring that your application is secure, including manual reviews and static code analysis. And another layer is penetration testing. So somebody going to your application and trying to, well, break it in some way, crack it, they get into it in a way that they shouldn't be able to. And pen testers use some tools. And one of the most widely used tools is this Zed Attack Proxy, or ZAP for short. This is an open source project and a very popular one. I think it has something like 10,000 stars on GitHub. 11 and a half, so roughly 2 times as much as Orchid Core has, which is already a very popular project. And ZAP is pretty much a security scanner. It can check your application for security issues. Now, this is a Java application, and it checks web apps for general web application security issues. So it won't know about Orchid Core, and for example, won't know about Orchid Core's roles and role-based access control to attack specifically that. But it can do generally dangerous attacks. It can do that actively and passively. So let me actually show you how you would work with that, and then we'll go into how to automate such scans. So I have a blog running here. Let's see how we can attack this with ZAP. So I will copy this URL here and open the desktop app of ZAP. This is what's generally recommended to be used, especially if you start with ZAP. And what it provides you as well with a dashboard to run such scans. Actually, there is another way. I think that manual explore would be would configure ZAP to act as a proxy, because apart from ZAP attacking your application and crawling through it and trying to find security issues, there's also an option to use ZAP as a proxy while you manually go through your application, or well, while some other automation goes through your application. We won't do that. Instead, we will let ZAP do its thing alone. And now we could use automated scan, and this would be pretty simple, but well, we are engineers, so we don't do it because it's easy. We do it because we can make it hard. So let's actually do that. And a much cooler feature of ZAP is this automation. They call it automation framework. And this quick automated scan here is a simple way to create a scan, but it's very limited in all ways. But the automation framework is pretty much how you script the ZAP. This way you can create automation framework plans, which will be YAML files in the end, and tell ZAP what to do. You can create a new automation framework plan here, and we can start from a so-called profile, which is basically a kind of a preset. And we can do something like a baseline scan. A baseline scan all has a spider job that will crawl through the application, find every page it can. It also has an AJAX spider that will try to do the same thing for SPAs. And then it has a passive scan. A passive scan is that it will just process the requests and show you if there are any security issues, like HTTPS not being used, or cookies not being not having the secure flag. A bit more would be to also use an active scan that's not selected here. An active scan would actually try to actively attack the application, trying cross-site scripting forgery, cross-site scripting, trying cross-site request forgery, trying all kinds of abusive inputs on forms, in requests, and everywhere else. But that takes actually a lot more time. So let's try with the baseline. Let's start with the baseline first. And now we have a plan here. These lines here are the different jobs they call. And we can tell ZAP here in the default context to start with our URL. And then two other things I will change. I will remove the Ajax spider because that's also slow, and our site is just a simple site. It's not a single page application. And secondly, just to make it more fun, I will instruct it to display its scan report right at the end. And now let's run it and let's see what happens. That was it pretty much. And here we have our report. And well, this is how it looks like by default for a vanilla version core. And yeah, we have a couple of alerts here. Luckily, no high-risk security issues in Orchard. Only a couple of medium and low ones, as you can see here. And we can actually scroll down and see the exact issues. And we'll see that these are not huge problems, and they are really configuration issues. And configuration issues like strict transport security header not set, they are here because I'm running the site locally. You don't use strict transport security locally, of course. Or CSP headers are missing. Yeah, they are missing because we haven't configured the security module for that. So ZAP can find simple things like this and a lot more complicated things too. Now, this is good and all, but what if we want to run this automatically and not manually from the ZAP desktop app like I just did? And in our UI testing toolbox, we now have a feature for that. And the feature request for this was actually, I think, asked by you, Sebastian, during one of my former demos, like last year. But then I went here and opened the issue for it. And quite recently, we discovered ZAP and that you can automate it. So now this is now done. And as part of a UI test suite of your application, you can execute security tests or security scans as well. We have some quite detailed documentation about this, or sufficiently detailed documentation here. But what's more important, we also have some samples. These specifically. This is a test class here. As you can see, it's a standard XUnit test class that has some 3 sample tests here. And this is how you would start. From a UI test, you would call this method that runs the baseline scan that I just showed you, and well, asserts on the results. Because while ZAP is a Java application running as a desktop application, you can also run it via the CLI in Docker, but that's still not really convenient. What we allow you to do here is run it with a .NET API. And well, this is a simple one, a simple scan, but you can actually utilize the .NET API more if you add some more configuration, as you can see here. So this scan here adds some configuration. For example, this, by the way, also runs on the same site with the blog recipe, set up with the blog recipe. And for example, you can exclude URLs from the scan. Here I exclude basically everything apart from the homepage and the /about page. Because by excluding URLs, you can exclude repeated pages or pages that you otherwise somehow don't care about to make the scan faster. And you can also disable rules. You can disable rules for just a given URL. You can also authenticate. And we are talking about testing, so you can also assert on the results. And the results are actually available not just in a human readable HTML report like what I've shown you, but also as a JSON serif log, which is a standard way of sharing such scan results. And that's also available in .NET. So you can actually explore from an assertion, and you can explore this object where all the alerts are available in this result, and well, assert whether the test results is what you expected. And now we can actually run this. Or this test would pass, and this test, as it is originally in the sample, would also pass, but now I made it fail by changing this assertion here. So let me run this here, and let's see what happens. Such tests, well, UI tests are much slower than unit tests to begin with, obviously. Security scans are also relatively slow, or I would say slow because slow compared to ZAP, but they take some time. Usually, such a scan, a passive scan, takes a couple dozen seconds for a simpler site, while it crawls through the whole site and does the checks. And this is just a baseline scan with a passive scan. But if you also turn on the active scan, then it can be a lot more, minutes even. Well, this was 30 seconds, not too bad. And what happened here is, we now have a test output with everything that we don't care about right now. But in the test output, we also see that, this is where ZAP started behind the scenes. And it set itself up. You see, again, we have passive scan here. That's the same passive scan I've shown you. And eventually, it created the report. And, well, the test failed on our assertion because, well, it found 33 alerts instead of 3, what I added there. And the results are available in what we call a failure dump, which is a dump of this test. And this is something that, for example, would be available as an artifact in a CI system. And yeah, I can't open it because it's still 1960. Well, not that, but this is due to some long pass issues of Windows. So let me copy this over to just the downloads folder. Let me copy it over to the downloads folder. Okay, now it's happened. And let's try to open this. And here we have our report. This has actually a little bit different design than what I originally showed you, because that was the default design. This is a customized one. And yeah, but here we can still see same kind of results. CSP header not set. We have fewer alerts here because remember that I excluded the block from this scan. And here you can also figure out what exactly the issue was. It's quite a detailed report. You can work through that. So pretty much this is it. This way you can add automatic security scanning to your UI test suite. These scans can then run automatically on pretty much every push for every pull request. If you introduce a regression, it will trip. You can configure these scans completely. So whatever you can configure in ZAP, you can also configure for these scans. And generally, you can use the full power of ZAP. I actually opened an issue about running such scans for Orchard Core itself too. So if you agree, or if you like to see this as well, please chime in here.